Hello, I'm Dr. Steven Steiner, President, CEO, and founder of Aerogel Technologies. Our company specializes in designing and bringing to market advanced, lightweight, multifunctional materials to solve the world's grand challenges and to enable spacefaring civilization. Aerogels are a class of incredible materials with properties unlike anything else. They are the world's lowest density solid materials, comprised of anywhere from 50 to over 99.9% air by volume, and include the world's best thermal insulating solids. Aerogels, despite the fact that they're almost completely empty space, can hold thousands of times their weight in applied force. Yet, to date, traditional aerogel materials have been impractically brittle for real-world applications. Recently, our company has brought to market a class of new aerogel materials we call Airloys. Airloys have all of the mechanical strength and durability you would expect of engineering materials, yet are 3 to 15 times lighter than plastics or composites. Like other aerogels, Airloys are superior thermal and acoustic insulating materials, making them useful for a wide variety of technological applications. Since then, I've always found it fascinating that materials that are almost completely empty space can do so much. How is it that something that's over 99% air by volume can bear so much load, can withstand so much heat, can even exist at all? But if you think about it, this motif of empty space is ubiquitous throughout the universe. Atoms are mostly empty space. The solar system is mostly empty space. And it's in understanding the interactions of a small amount of something distributed in a lot of nothing that allows us to engineer limitless possibilities. Aerogels may be able to hold thousands of times their weight in applied force. However, traditional aerogel materials have been impractically brittle for real-world applications. If you were to look at an aerogel under an electron microscope, you would see it's comprised of a sponge-like skeletal structure of interconnected particles. But these particles are only weakly bound to each other. There's not a lot of surface contact between them, and this makes the resulting macroscopic aerogel brittle. At Aerogel Technologies, we've re-engineered the empty space of aerogels in 2 ways to improve the mechanical properties to make them viable for real-world applications. The first way is through nanocompositing. We zoom into that skeletal structure and coat the conformal interior surfaces, all of the nooks and crannies along the struts of that skeletal structure, with a conformal polymer coating that dramatically improves the strength and toughness of the aerogel material. Think of it like a marshmallow coating in a Rice Krispie treat. The second way we do this is by creating contiguous networks where there are no interparticle connectivities, rather continuous streams of fibers branching in a fractal-like structure throughout 3-dimensional space. These materials are the basis of our Airloy line of products. Airloys and other aerogel materials start their lives out as a wet gel, in some cases physically similar to edible gelatin like Jell-O, although in other cases this material can actually be quite tough. If the liquid in a gel is merely evaporated, capillary stresses will arise and cause the gel to shrink and collapse into a densified material that is not an aerogel. Instead, the liquid in the gel can be heated and pressurized past what's called its critical point, at which it transforms into a semi-liquid, semi-gas that can freely diffuse out of the sparse solid skeleton that gives the gel its rigidity. That fluid can then be depressurized to ambient conditions, leaving behind a low-density solid material that we call aerogel. Now, some people think that supercritical drying is an impractically expensive process, and although it is complicated and very specialized, it can be done economically at a large scale. Aspen Aerogels, for example, manufactures its aerogel blankets at large scale using this technology. Others have used an approach called subcritical drying to manufacture aerogel materials. However, this approach is generally limited to aerogel particles and very small monoliths. Cabot Aerogel uses subcritical drying on an industrial scale to make their aerogel particles. We have developed a remarkable new drying technology that we call the Stelmach process. This technology allows us to manufacture aerogel and airloy materials in large sizes and in large quantities at a fraction of the cost of supercritical drying or traditional subcritical drying. This enables us to address opportunities in multi-billion-dollar markets, including aviation, automotive, healthcare, construction, and commercial space transportation. How exactly this technology works is a trade secret. However, we want to bring this technology to scale so that the world can benefit from the materials properties of aerogels and airloys in ways that were previously not possible. Aerogel Technologies has a strong IP position in the field of mechanically strong, multifunctional aerogel materials. Our growing patent portfolio includes the foundational IP for X aerogels, the original polymer cross-linked aerogel technology, transparent super insulation, multiple mechanically strong organic aerogel compositions, high temperature mechanically robust super insulation, mechanically strong structural electrodes, and bullet-stopping aerogel compositions. In addition, Aerogel Technologies actively develops new materials technologies both inside and outside of the field of aerogels, as well as new manufacturing processes, securing our role as a disruptive technology leader for years to come. Airloy Ultramaterials offer a tremendous value proposition over plastics and composites anywhere weight and cost are coupled. Take airline interiors, for example. Airlines go to great lengths to eliminate unnecessary weight from their fleets wherever possible. Everything from redesigning seats to ditching magazines and seat back pockets, since every ounce means added fuel and added costs. Today, the airline interiors industry is a $7 billion market, growing at a rate of 12.1% annually, thanks in part to a global upswing in new vehicle purchases and greater demand for fuel efficiency. However, two major pains in this market include that a reduction in interior weight often results in a loss of functionality, and there's little choice available for innovating new interior solutions since few materials meet the burn certification requirements for aviation applications while simultaneously providing actual engineering advantages. That's where Airloy Ultramaterials come in. Airloys are 3 to 15 times lighter than the sheet-molded composites and bulk plastics used to make overhead bins, tray tables, and wall linings on airplanes today, and most notably, don't burn, smoke, or drip when exposed to flame like other materials, meaning they easily exceed burn test requirements. Additionally, airloys are equivalent or superior thermal insulators to things like Insulite, fiberglass, and mineral wool used on airlines today, and are better acoustic dampeners than conventional soundproofing, meaning that airloys combine structure, thermal insulation, and soundproofing into a single material envelope, eliminating the need for multiple function-specific materials, further reducing weight. Take a Boeing 737-300, for example. At 8,200 pounds, the average interior for this vehicle represents about 5% of the gross takeoff weight of the plane. Using Airloy Ultramaterials to replace various furnishings in the cabin interior, we believe we could reduce this weight to 6,600 pounds, thereby saving about 3,500 pounds of fuel per flight. Multiply this times 4 flights per day, 320 service days per year, and a fleet of about 350 planes. This would result in a savings of about $500 million to $1 billion in fuel costs alone for an airline, while simultaneously providing a superior cabin interior experience for the customer. Additionally, because airloy panels are so light, installation is dramatically simpler than for sheet-molded composites. As a result, we see the airline interior market as an ideal initial opportunity for airloys. Market pains that we can solve today, a high willingness to pay given the substantial operational cost savings that results from their use, few alternatives in the marketplace, and given that 78% of the global market is consolidated in just 3 players, a relatively straightforward path to market penetration and global impact. Notably, Aerogel Technologies has already worked with the 2 leading players in this industry, as well as the world's leading aircraft manufacturers. We are currently seeking 25.853 burn certification for our materials with the intent of doing a 727 interior modification by the end of the year. Aerogel Technologies is currently a late-stage startup transitioning into its growth phase. Over the past 4 years, we've focused heavily on the development of scalable manufacturing processes for the production of shaped and mechanically strong aerogel materials. Our company has financed its growth primarily through online direct-to-user sales of traditional and Airloy aerogel materials through our website buyaerogel.com, as well as by providing custom aerogel solutions in the form of contract synthesis and applications engineering. We expect our company's growth to continue to accelerate over the next few years, as the versatility of our products poises us to disrupt numerous fundamental technologies other than just thermal insulation. For example, structural plastics, aviation materials, and new technologies for the commercial spaceflight industry. Join us. Help us create the future of materials technologies. Visit us online at aerogeltechnologies.com to start the conversation, or experience our products firsthand at buyaerogel.com.